Okay, last problem here, I think. Um, Given that same vector field, I want to confirm the answer from the previous problem using a parameterization on all 4 segments. So you can see a little bit of the picture, the graph that I've drawn here. I'll pull it down to there. Um, so if you want to go ahead and give it a shot, you can. You're going to do this line integral, that line integral, that line integral, that line integral, and then add them all up. Give it a shot. Hit pause. Um, Now I'm going to go over it. You should know if you're right because you should get the same thing. But take a look at my work here. So I do all of those individually, and then I add them all up, and I get that piece right there. So let's go through one by one. All right, so for C1 here, notice I'm on the x-axis there, so y is equal to 0. That means dy is going to be 0 too. You could think about it as y doesn't change, or you can just do the differential of this, right? Um, Either way, dy is 0. X is going to span from 0 to 2. So I do the integral from 0 to 2 of, I leave x as x, I change all the y's to zeros, and then dotted with dx, and then remember dy is 0, so I get a 0 there. That's really convenient because this, when I do my dot product, gets multiplied by this, so I just get dx times this. And since I got a 0 cubed there, it's really just the integral from 0 to 2 of x dx. So that's like really nice and convenient. That's 1/2 x squared evaluated from 0 to 2, which gives me 2. So the work done from here to here would be 2. Now I'm going to do the same thing going from here up to there. So that's C2. You can see that um, x starts at 2 and it ends at 2 and it goes up straight up. So x is just 2. It doesn't change. What's dx then? It's 0. And then y is going to span from 0 to a. So the integral along C2 of f dotted with dr is integral from 0 to a. And then look, I get a 2 minus y cubed. Where did the 2 come from? That's what x is. And that's plugged into this. Zoom out a little bit. So this 2 gets plugged into there. The y cubed stays as a y cubed. This becomes y cubed. And then when I plug in x equals 2, I wind up getting an 8. Now, I really didn't have to do this part right here, because remember, dx is 0. So when I do that dot product, this is going to get zeroed out. So really, I just have to do the integral of this dy from 0 to a. So that's integral 0 to a of y cubed plus 8 dy. Do power rule, I get 1/4 y to the 4th plus 8y. Evaluated from 0 to a, which gives me this thing. Now, I'm not going to lie, when I was doing this myself, I just like, I felt like, man, there might be an error here because I got this a to the 4th over 4 plus a, or sorry, plus 8a. And the problem with that to me, like, was, well, this is a cubed, right? So how am I gonna have an a to the 4th and get it down to an a cubed? Like I would have to divide it by something, but things are going to only be added and subtracted. And I actually like went and double checked my work here and here, and I thought about it. I was like, oh yeah, maybe I could get another piece that will cancel out with that. So I'm going to leave that. It jumped out at me at first as like, uh-oh, something's wrong. But it's okay because we're just going to keep going with it. So let's do C3. I'll zoom out a little bit more. And then I'll go back in after I talk about this stuff. So C3 is Y is A. I'm going from this spot to that spot. So Y is A. dy is 0. And then X spans from here to there. So it goes from 2 down to 0. So when I plugged all this stuff in, like, all right, dy is 0. This is going to be 0. I don't even care what this is. I'm just going to leave an open blank space, right? because that's going to get multiplied by 0. So that doesn't matter what it is. So really, I'm just doing the integral from 2 to 0 of x minus a cubed dx. So what I did was, I really don't like integrating like backwards along an axis. It just bothers me. And if I can't get rid of it, I will. So just because I'm so used to doing an integral from 0 to 2 and not from 2 to 0, and I feel like it's error prone. So what I did was I flipped the bounds. 2 to 0 went 0 to 2, and then I negated everything. That's property integrals that we can use, and you should be good with that. So I get a cubed minus x inside of my integral, and I'm integrating from 0 to 2 dx. Well, that gives me a cubed x minus 1/2 x squared evaluated from 0 to 2. And then that gave me my 2a cubed minus 2. So the work done from here to here is 2a cubed minus 2. Oh, I said I would zoom in. I'm sorry. Hopefully you could see all that as I was talking about it. All right, so last part is to do C4. So I will zoom out and hopefully remember to zoom back in. But C4 is this spot down to that spot. So x is 0, dx is 0, and then y spans a down to 0. Integral from a to 0 of this. I left that blank because I knew dx was 0, so I was going to multiply my dot product in there. And then a dy gets multiplied by this. So I will zoom in. From there, this one I did not flip it because I would have had to make this negative, and that is more annoying to me than having a to 0. This one, it was easy to flip these bounds to these bounds because I just flip-flopped which ones were being subtracted. Here, I didn't want to do it. You could do it, it doesn't matter. Just justifying what I'm saying, doing, writing. You got me. All right. So I get integral from a to 0 of y cubed dy. That's 1/4 y to the, there should be a fourth power up here, evaluated from a to 0, which gives me negative a to the 4th over 4. And at this point, I was like, oh, sweet. And why was I like that? Because this is the opposite of this guy. So this guy is going to get rid of that piece there, right? And when I think about it in big picture, it's like, it makes total sense because it's like going forward. Or this was the up along the A's, and this is the down along the A's. So it makes sense that those things cancel. So the last thing that I do is the integral along the full path. I could do a closed sign here if I wanted, of f dotted with dr is I shorthanded this. C1's integral plus C2's integral plus C3's plus C4's. So I just took this and this and this and this and wrote them all out down here. I got the 2, a to the 4th over 4 plus 8a, and then I got the 2a cubed minus 2, and then I got the minus a to the 4th. And what happens, and it's awesome, it makes me so happy. I hope it makes you happy too. You know it does. Maybe a little bit. Maybe some of you look at me like, come on, man. Anyway, makes me happy. I got the 2. I subtract the 2. I got the a to the 4th over 4. Subtract the a to the 4th over 4. What am I left with? 8a plus 2a cubed, which if we go up to the previous question, same thing, right? So, yeah, hopefully, like I said previously, these line integrals are starting to make sense, and you feel pretty good, especially when we are calculating work. Okay, bye.